Chapter 6.1, exercise 1 through 12, page 511. This is a series of exercises that has to do with vectors. And I'm going to do here the odd numbered problems, 1, 3, 5, 7, 9, 11. In exercise 1 through 4, prove that vector RS and vector PQ are equivalent by showing that they represent the same vector. What we have is a technique used to find values of vectors called, actually I'll put the acronym first, HMT. What does HMT stand for? It stands for head minus tail. Head minus tail. All right, the head is where the vector finishes, and the tail is where the vector starts. And so if we look here, for instance, at RS, vector RS, S is going to be where the vector finishes, which is going to be the head. So I'm going to put H next to S, and R is where the vector starts, so that's going to be tail. So we take the head minus the tail. So it's a matter of organization. What I'm going to do is take head, which is S, and then that coordinate pair at S is -1, 5. I'm just copying here, head, and then tail, R, and that coordinate pair there is -4, 7. And therefore, vector RS is going to be equal to, I'm going to make the angular brackets denoting component form of a vector. And that is going to be, now we need to use our integer arithmetic, -1 minus -4. -1 minus -4. Well, -1 minus -4 is the same as -1 plus 4. So that's going to be 3. And then 5 minus 7 is -2. Now we're going to go ahead and work on PQ. And here's PQ. And Q is going to be our head. And our tail, or starting point, is going to be 0, 0. And so just right the point here, we have head, Q, and that coordinate pair is 3, -2. And P is going to be our tail. We're going to subtract. It's going to be 0, 0. And so vector PQ, we have vector PQ is going to be equal to, angular brackets again, 3 minus 0 is 3, and -2 minus 0 is -2. Okay, it says prove. Say, make it kind of a statement using HMT, head minus tail method. Okay, we have RS, vector RS equals vector PQ. There we go. So a little summary statement. So that's problem number 1. Let's go to problem number 3. Same technique, RS and PQ. So we have head minus tail. Yes, so we have head minus tail. And then for PQ, we have head minus tail. So it's a matter of organization again. So we have vector RS Let's go ahead. There's what I want to do. I want to put head S and then R here. So just kind of set up the format. Okay, and then over here for PQ, we're going to have Q here and P here and organization. S is 0, comma, -1, and R is 2, comma, 1, and Q is -1, comma, 2, and P is 1, comma, 4, and vector RS is equal to angular brackets 0, -2, -2, -1, -1, -2. Over here for vector PQ, okay, so PQ, here we have, okay, that's going to be angular brackets, -1, -1, -2, 2 minus 4, -2. All right. Okay, using HMT method, okay, RS, vector RS, and vector PQ, are equivalent. Okay, let's go on to number 5. This is a different exercise set. In exercise 5 through 12, let P equal -2, comma 2, Q equals 3, comma 4, R equals -2, comma 5, and S equals 2, comma -8. Find the component form and magnitude of the vector. And so PQ, okay, that's going to be head minus tail. So we're going to put Q, which is head, and we're going to have P, and Q is going to be 3, comma 4, and P is going to be -2, comma 2. And we're going to subtract, and vector PQ is going to be equal to angular bracket 3 minus -2. 3 minus -2 is the same as 3 plus 2, or 5. And 4 minus 2, that's going to be 2. Okay, so that's going to be vector PQ. And then magnitude. A magnitude, MAG for short, is going to be quantity x2 minus x1 plus quantity squared plus quantity y2 minus y1 squared. We've already figured this out here, that x2 minus x1 is 5, so we have 5 squared here, and y2 minus y1 is 2, so we get square root of 5 squared, which is 25, plus 2 squared, which is 4, so this is going to be equal to the magnitude square root of 29. I don't think that can be simplified. And that's our That's our magnitude. Magnitude equals square root of 29. Distance formula, Pythagorean theorem, that's all it is. Problem number 7, QR. Okay, head minus tail. Okay, R is the last one, so R is the head. The tail is Q. So we have R and Q. And when we figure that out, we're going to have vector QR. It's going to be equal to what we find. Here we put the point for R, -2, 5, and point for Q, 3, 4. -2 minus 3 is going to be -5, and 5 minus 4 is 1. So that's going to be vector QR. And going over here to magnitude, we use the same distance formula. Squared. Sometimes these formulas I just like filling in the blanks, or the basic format, and just put in the numbers. So x2 minus x1 is going to be -5. If we did, we take -1, -2 minus 3, -5 squared. And then y2 minus y1 is 1. And so -5 squared, -5 times -5 is 25. 1 squared is 1. So we're going to equal to the square root of 25 plus 1, 26. That is our magnitude. So there we have it. Okay. Problem 9. A little complexity. We got 2 QS. Well, S is going to be our head, where the vector finishes. And then our tail is going to be Q. So I put our tail right here. And we're going to have S minus Q. And we just put the coordinate pairs right here. S is 2, -8. And then Q is 3, 4. And QS, vector QS, is equal to 2 minus 3, it's going to be -1, and -8 minus 4 is -12. And so what we have here is 2 QS is equal to 2 times, take 2 outside and multiply times the vector 1, -12. And that is going to be equal to -2, -24. So that's going to be 2 QS equals -2, -24. All right. Let's go look at our magnitude. Okay, magnitude is going to be equal to same thing as you did before for problems 5 and 7. x2 minus x1 squared plus y2 minus y1 squared. Distance formula, that's all it is. So we're going to put negative 2, x2 minus x1, and y2 minus y1, negative 24, 24. So negative 24 squared, I do not, negative 4 squared, I have that on the tip of my tongue. That's going to be 4. I think that's going to be 576. Let me see. 24 squared, 24 squared, 576. That's what I remember it was, 576. So that's going to be equal to square root of 580. Can we pull anything out of this 580? Well, 580 is divisible by 2, so we can rewrite, let's see, 580 equals 2 times, that's going to be, what, 290? And then 145, let's see, and 2 times 290 equals 2 times 2 times 145. And so what we have is magnitude equals square root of 4 times 145, and we can pull our 4 outside the radical, so we have 2 times quantity 145. So that's our magnitude. Square root of 580, that's probably good too. You don't need to get all crazy. Simplest radical form. All right. Number 11, 3QR plus PS. All right, so let's go look at this. We got QR. Okay, that's going to be, R is going to be your head, and Q is going to be your tail. And then for this other vector, S is going to be your head, and P is going to be your tail. So I kind of color-coded. Go back to the red one first. We have R. It's going to be negative 2, 5. And Q is going to be equal to 3, 4. And so QR, vector QR, is going to be equal to negative 2 minus 3, which is negative 5, and 5 minus 4, which is 1, and 3QR is going to be 3 times negative 5, 1. So 3, bringing this down, 3QR equals 3 times negative 5, negative 15. And then 3 times 1, 3. All right, let's go ahead to this second one, PS. So S is our head, and that's going to be 2, negative 8. And P is going to be negative 2, 2. And we subtract. So vector PS is equal to, bracket, 2 minus negative 2 is the same as 2 plus 2, so we're going to get 4. And negative 8 minus 2 is going to be negative 10. So 3QR plus PS is equal to negative 15 comma 3 plus 4 comma negative 10. So adding these together, 3QR plus PS equals negative 15 plus 4, which is negative 11, comma 3 plus negative 10, which is going to be negative 7. So that's going to be our vector 3QR plus PS. Okay, magnitude. Magnitude equals, we have negative 11 squared plus negative 7 squared. So magnitude, negative 11 squared is 121, and 7 squared is 49, and negative 121 plus 49 is 170. So our magnitude of this vector is going to be square root of 170. Anyway, that's all the odd number problems in this set 1 through 12. I hope this has been helpful. Good luck on working out your even number problems. Thank you for viewing.